All right, hello everybody. It's Unit 3, Day 2, and today we're going to cover the quadratic formula. The quadratic formula is a formula that will allow you to solve any quadratic, whether you can factor it or not. The formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where the a and the b and the c are just the coefficients of the quadratic when it's in standard form and set to 0. So let's do an example or two, and I'll show you how the formula works. Here's example 1. 2x squared minus 3x minus 4 equals 0. And since it's in standard form, already set to 0, it's good to go. We're just going to list our a, b, and c. A is this coefficient here, which is 2. B is the coefficient next to the x. And c, of course, is the constant. So they just go in a row, A, B, C, but no x's. And then we're going to plug right into the formula. I would like you to write the formula every time that you're going to use it. It will help you memorize it. You'll be deducted a point if you don't list the formula before you plug into it. So let's go x is equal to, b was negative 3 plus minus that negative 3 squared minus 4 times the a times the c all over 2 times a. So this negative 3 will just make a 3. On the bottom, 2 times 2 is 4. But I would find this underneath computation without the radical in your calculator because it may or may not be a perfect square. So let's just do the math under here. Negative 3 squared will be 9. And then I have 4 times 2, which is 8. 8 times 4, which is 32. And I have a negative times a negative. This whole entire blurb here, the second part, is going to be a positive 32. Which means I'll have 3 plus or minus the square root of 41 all over 4. And that is going to be my final answer because 41 does not break down. It's not reducible. Now, if you're wondering about the plus minus, we spoke about that once earlier this year. All it means is there are actually two answers. 3 plus radical 41 all over 4 and 3 minus radical 41 all over 4. So if at this last step you want to split it and show me these as your two answers, totally fine. If you wanted to leave it like this in one box, that's also fine because here the implication is that there are two answers, one with a plus, one with a minus. But there are actually two roots for this particular quadratic. The fact that we've got this radical means the roots are irrational, which means that it'll be a decimal if you try to put it in the calculator. And what that also tells you is this original thing could not be factored. There are no factors that would have worked, and that's why I'm ending up with decimal roots. All right, let's look at example 2. Example 2 is x squared minus 12x plus 29 equals 0. Again, I'm set to 0, I'm in standard form, and it looks like something that you should factor. So you might take a few minutes and think, oh, what multiplies to 29 but would get me to 12? After a little bit of investigation, you'll certainly realize there are no factors of 29 that make 12, right? This is not factorable. Instead, you've got two options, complete the square or the quadratic formula, and that's what we're doing today. So for quadratic formula, you're going to list your a, your b, and your c. Your a, of course, is an invisible 1. It's just the coefficient. B is negative 12, c is 29. And then we're going right into that formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. B again is a negative 12, so it's negative b, so it's a negative 12. Negative 12 squared minus 4 times 1 times 29 all over 2 times 1. I end up with 12 plus or minus a 2 on the bottom. And then this part we're going to have to do a little work at. Negative 12 squared is 144. 4 times 1 is 4 times 29. 4 times 29, I think it's 116. And then 144 minus 116 looks like 28. At this point, I do have a little more to do because this 28, we can break it down like we did in our previous unit with the radicals. The breakdown, of course, will be 4 and 7, and the 4 is going to come out front as a 2. So now at this point, I'm at 12 plus or minus 2 radical 7 all over 2. And then something else you might remember for our last unit, if all three of these numbers are divisible, we made kind of like a heart around them, you should reduce those. So this will be a 1, and a 6. So my final answer here will be 6 plus minus rad 7. And really what that means is there are two answers, right? 6 plus radical 7 and 6 minus radical 7. All right, folks, one more example and that'll do it for today. I'll show you one more time with something that just does one more little thing a little bit different. Example 3. X squared minus 2x plus 6 equals 0. Again, so nicely you might be thinking I'll factor, oh, what multiplies to 6 and gets me to 2? There are no factors that will make this work. So that means I'm going to use the quadratic formula. I'm going to list a, b, and c, which are again just the coefficients. A is 1, b negative 2, c 6. We're going to plug them into the formula. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And we're going to plug into that. So negative 2. It's just a coincidence that we've had a negative b every time. That doesn't always happen. Negative 2 squared minus 4 times 1 times 6 all over 2 times 1. I have 2 plus or minus 2 times 1 is 2. But let's look at this underneath the radical piece. Negative 2 squared is 4. 4 times 1 is 4 times 6. This is going to be 24. How about that 4 minus 24? What will that give us there? A negative 20. So now again, I do have to reduce or break down this negative 20. My breakdown is going to be negative 4 and 5. And the negative 4, you will recall, is going to come out front as 2i. So now I'm at 2 plus or minus 2i rad 5 all over 2. And then one more step, again the heart. All three of those 2's can reduce and become 1, 1, 1. So my final answer here will be 1 plus or minus I radical 5. So yes, you can get i's here if you end up with a negative underneath. All that means for the quadratic is if you had typed this into your y equals menu and looked at it, the quadratic would not have touched the x-axis. So there are roots, but the roots are imaginary. So that's the scoop with the quadratic formula. I'll give you a couple of blank ones here. If you would like to try a few examples on your own, you can. And if not, be ready tomorrow to talk about what you found easy or difficult or where you have questions. Here's an x squared plus 9x minus 17. A 2x squared minus x minus 1. X squared plus 6x plus 11. Any of those would be good examples to try. Remember, if you finish your quadratic equation and end up with real roots, no radicals, no decimals, no i's, all that means is your original quadratic could have been factored. Sometimes you recognize right away, oh, nothing's going to multiply to 11 and get me to 6. But other times, if it's something like this hard trinomial with the number here in front, you may be unsure if that factors or not, and you may find it quicker to just go ahead and use the quadratic formula. So these are 3 nice examples for you to try. Be ready with questions tomorrow for class. And that's it for tonight. Thanks so much. We'll see you tomorrow.